Hello, my name is Bob Norman. What I'd like to do today is show you what I've been learning in labView. I downloaded an evaluation package and then I went on YouTube and bought a book and I've learned some stuff. On YouTube, I learned how to take a state machine and implement it in labView. The reason I wanted to do that is I know that people traditionally use labView as a method of gathering data and recording it, but I wanted to look at it from the perspective of a control system. They have some controllers called Rio, and I wanted to try and understand how you would control a process. The process I decided to look at was a brewery. I'm familiar with that process, and a lot of people are interested in microbrews now, and so I'd like to explain some of the things that happen there. I don't actually have a full brewery, so what I did was to emulate a model and show the control systems that would go into that. Upon conclusion of showing this software, I'm going to go ahead and show you the front panel so you can see what's going on. This is what's called a block diagram to show the process, what goes on behind the scenes. So what we have here is a case statement, and this case statement shows the different states in a diagram. So if you were to look at a state diagram, you'd end up with some kind of a process that looks like this. Oh, I'll show you the details as we go along. But basically we want to go through one state to the next. So the presentation I found on YouTube showed that you can take a case statement here. You start with some default value. Now this case statement has a selector right here, and then we put this case statement inside this outer while loop. So the while loop is going to continue to go around until we hit a certain case or state where that state is equal to stop. When we hit the stop, we exit the while loop, we're all done. So what you'll see is we start here and we'll have an if then else. We'll stay in this state until we get to the some condition here that says go to the next state. This goes to an output. It goes to what we call a shift register. The output of the shift register goes right back around to the front end here and tells us what the next case should be. So the next case should be heat HLT to strike. Before we leave this is our first state. What we do here is we do some initialization of temperature, levels in our different kettles, our mash tun, boil kettle, etc. We initial all our timers to 0. Here we have some recipe information, how many hops in the first edition, the second, when to add those hops, how much yeast to pitch, information about the boil time, and so on. Now we communicate from within the case statement over here to some of the different controls. You'll see a control for the mash timer. There's some indicators here, tank level indicator, temperature indicator, a control for setting strike temperature, sparge temperature, etc. So all this stuff around the perimeter are controls. I put some of these timers out here. I could have easily put them inside the different states, but they span different states. So to me it made more sense to put them out here since they span multiple states. So one state could turn it on and another state would turn it off. Let's take a look at our next state now. We'll go to that state when we fill up a tank. We're going to increment it in 0.02 steps every 100 milliseconds until it's full, or we get to a 1, and then we go to the next state. The next state says to heat up some water till we hit a strike temperature. We start at 55 and we start adding 5 each time, again in 100 millisecond steps. And then when we hit that temperature, we go to the next, which is transfer water to the mash tun. So we go from the hot liquor tun. We're going to decrement here. So here we've got an integrator going up, but we subtract from 1, which is a full tank. And at the same time, we're going to increase the level in this mash tun. So we're transferring from the HLT to the mash until it gets to a value of 1. Also during this time, we put hot water into the mash tun, so the temperature is going to go up. And here I just said we're going to start at room temperature of 72, and it's going to get up to 152, which is mashing temperature. So the strike temperature is a little bit high, added to some cold grain, and there's formulas that said it should hit about 152. Go to our next state, and our next state is to refill the hot liquor tun. We drained it down a bit, and we need to add some more water. When we entered this state, we start our mash timer. So we want to know how long it takes before we get to the end of the mash time. Here we're just going to fill it up to 1, and then we'll start to heat that up in the next one. Starting again with our cold water of 55, going up in 5 degrees steps until we hit our sparge temperature in that hot liquor tun, going up right here. When we hit that, we're going to go to the next state, and here we're just waiting for the mash timer. When the mash timer is done, we're going to toggle. So we're going to take liquid out of the mash tun. Again, we're decrementing it down, or transferring it to the boil kettle, and some of the water is going to remain. So here I said we're going to get about 72% out. Typically we'd have some kind of system to look for the flow to come to an end, but here I just said it's going to be about 72%. When that occurs, we're going to go ahead. Here again, temperature change, mash timer gets turned off, and the boil kettle temperature goes off because we put hot water in there. Go to the next state. We're going to transfer some of the water from the hot liquor tun over to the mash tun. We had filled it up, and we knew we didn't completely drain it, so here the initial condition was 0.28. That complements the 72%. So now we want to fill that up to 56, and the reason I did that is it's 56 times 2. It'll probably drain right back down to the 28 again, so 56 minus 28 is 28. And we'll be adding that later over to the boil kettle. Here again, mash temperature goes up to the sparge temperature of 168. This is the hot rinse. Turn on the sparge timer. Wait for the sparge timer to conclude, and then we'll transfer water from the mash tun over to the boil kettle until it's full. We're going to see the temperature go up in the boil kettle because we added the hot water. Sparge is done. Turn that timer off. When we get the boil kettle equal to 1, then we go to the next state, which is to bring it to a boil. Started at 168, integrate up till we hit the boil temperature. There's probably a better way to do it. Some observation, maybe look for steam, something like that. Go to the next state, which is to add hops. Hops are typically determined by time. They'll say 40 minutes. That means 40 minutes from the end of the boil time. So boil time minus 40 is 20. We had started at our boil timer in the previous state or case. So when the boil timer is 20 equal to this 20, that's when we go to the next state. We also do our hop addition. I did it a little bit early just to make sure that it occurs before we change states. So when this is actually 20 minus 0.1 or 19.9, then we'll go ahead and add it. So our hop container goes from 88 down to 0 because we dumped the hops or pitched the hops into the boil kettle. We can repeat this several times. Simple beers will have a couple of hop additions. More complicated ones could have half a dozen. This is the same thing, second hop addition. And then we finish off our boil. Wait for the boil to be done. And then we go to a cool state. The cool state's been emulated with an exponential decay. This is just a mathematical model. So it starts at 212, and if it was allowed to go towards infinity, it would get down to our cold water temperature of 55. We want 55 because we'll pass through 70 at some point, and that's when we do our next state change or case change, where we transfer to the fermenter. Here again, two integrators, boil kettle to the fermenter. When we get there, we pitch our yeast. That's another container. 92% full, decrementing 2%, getting down to 0, and then we're done. We go to our stop case. Stop gets passed out to the shift register, into the shift register, compared to stop down here. Stop equals stop. We exit the while loop. The loop condition has been met and the simulation is done, or the control is done. So let's see what that looks like from the front panel. The operator just wants to see the processes going on and to have control without knowing all the logic behind it. Here's what it looks like. We fill up the HLT, and then we'll bring the temp up to the strike temperature here. Up she goes. Pour it over onto the grains, and there we go. We start our mash timer. In the meantime, we're refilling the hot liquor ton and bringing that up to the sparge temperatures. Mash would go. Here it's 20 seconds. Real life 60 minutes is typical. We hit our time, and then we'll transfer it over as much as we can to the boil kettle. Some stayed behind, so we added some sparge to rinse it. You saw it come down and then go back up as it was transferred. There we go. We went to the boil kettle, brought it up to a boil, started the boil timer. At 35 minus 24, which is 11 minutes in, we dumped our hops. First one. Our second one is 35 minus 5. The operator wanted to tweak the recipe. Boom, boom. Let's do it at 35 minus 7 is 28. There they go. Now we finish our boil at 35 here and start our cool process. It's exponential. You can see an exponential curve developing. And we're going to bring it down to 70 degrees. When we hit 70 degrees, it's asymptotically approaching 55, but when we hit 70, That's when it's cool enough to add our yeast without killing the yeast. There we go. We transfer it over and pitch our yeast slowly into the fermenter, and that concludes the process. My name is Bob Norman, and thank you again for